Hello everyone, today we'll know the concept of energy in ground state of hydrogenation. So we need to know the kinetic energy and the potential energy, and the energy which is the sum of the kinetic energy and potential energy. So here we'll go, and how this formula is come from the previous bonds theory. This is like mv square. So if we multiply the half here and half here, okay, so this is like we'll get the kinetic energy. Okay, so what is kinetic energy? So kinetic energy is like ke is equal to half, this is the half, and 1/4 absolute naught, we can say the k. Okay, and then it is e square by rn. So we can say this formula is come from there. And potential, we know that the work done will be converted in the potential energy, which is V into Q. This is a 10th grade formula, you should know. And what is V here? V, we know that V is K by E, Ke by R. Okay, so K, we know the K value, but we'll put this. And here Q is what? Like Q is the charge of electron. Q is the charge of electron, so will be the minus E, and minus Ke square by R. So this equation is come from there. Okay, now you know that's Ke, and this is the total energy. So we'll compare like kinetic energy and this. So we know potential energy is half Ke square by R. Okay, so from here, like we can say that the Ke square by R is equal to the 2Ke. So put 2Ke instead of Ke square by R. So Ke square by R. So here will be minus 2 of kinetic energy. Okay, and what about the total energy? So total energy we will write like from put Ke here is the kinetic energy, half Ke square by R, and put this is here in that. So and now the answer will become minus Ke square by R upon 2 also, and this will be we can say that this is also an kinetic energy. This is also a kinetic energy, Ke. Okay, so minus sign, with the minus sign, Ke. So E equal to minus Ke. The total energy is equal to Ke minus Ke, and potential energy is equal to minus 2Ke. This is the kinetic energy. Okay, so I'm done with this video. Thank you for watching.